Hey guys, let's do these heap problems from blind curated again. Uh, so Mars K sorted list. We already did this in linked list section, but now we will use. If you see the submissions, I think I already solved this using simple merge, right? Yeah. So now today what we'll do is we will basically use queues to maintain the heap and then do it from there. Okay, so let's do this. Let's say we have a priority queue, new priority queue, and this priority queue is of list node, right? And what we do is how we sort these values is whatever is the minimum should come at first, right? So if uh, so in a list it's a, yeah, so if it's a list node, then a dot value minus b dot value. This is what we would need, right? Sorry. So a and b will be a dot value minus b dot value. And now what we'll do is for every list node L in list, we will do uh, priority priority queue dot add, right? Uh, what will we add? We simply add this list. Uh, so we are adding all the individual lists. Now what we'll do is while priority queue is not empty, right? While this is not empty, we'll pull. So right now what we have is at first we'll have 1 4 5, then for this example 1 3 4 4 5 1 3 4. We added all this to the priority queue, and now these are all sorted by the values of its list node, head node. uh, so what we do is list node L, list node popped is equals to priority queue dot pull. uh, so once we pop this out, what happens is, so now we pop this list out, so we can, let's say we have a list node dummy is equals to list node of 0. So what we'll do, we'll append all these list values here. So now since this is the one in the heap which is on the top layer, so whenever we pull we get 145. So what we want to do is list node next is equals to popped dot next, right? So and what we want to do is if uh, next is not null, then so whenever we are at last, if it is not null, then we simply want to put it to the priority queue dot add this next node. And simply in this dummy, let's say we have a pointer list node current, which is a dummy, which is a reflexive dummy. So current dot next will be this pop dot value, right? So whatever value it has, and then current will be current dot next. This way we can finally return this dummy dot next. So this is a list node of type integer. Let's do this, not this one, but our priority queue is of list node. Okay, okay. Let's see. There is a runtime error on the null pointer. So on this case, so if L is not equals to null, then only we'll add. So in that case, what happens is should be good. Cool. See the runtime. Whenever we are adding it in a queue and then we do this, the runtime is just 4 millisecond, but here it was more than that, 366, and was a bit slow program. Uh, so the ordering here is n log n, and we find everything in the order of n log n, and for every node we traverse equally and then put it here. So the other way to do it is also, I think, what we can do is for all these values, right, we can use more sort, and then so what we do is we simply partition all these lists to equal, I mean different partitions, and then merge them together at the base. Hope you will be able to solve it like that, but if you want me to, I can do it again. uh, but for now this is how it is. Maybe in some sorting program, if this problems comes again, then we'll use selection sort, because that way we will learn how to use these data structures, right, which is the main aim of this series, blind curated series. Okay, now in the list we have okay, this one is done. Let's do the top k frequent element. um, so given a non-empty array of integers, return the k most frequent elements. So again, k most frequent element means, so we need two frequent elements. So here two frequent elements are 1 and 2, and so your other time, so yeah, so what we'll do again is we have a priority queue, right, since we are using the heap. Pq is equals to new priority queue. But this time what we are going to, so now we need to know which number occurred more, right? So let's just put a hash map first. Map of n is equals to new hash map. This map will be of integer, right? Then for every integer nums, what we'll do is map dot put in num map dot get or default value. If there is none, we'll simply pick none, else we'll simply say it is 0, and we'll add 1, so the count increases, right? So now we have the map for every numbers, and what we'll do is we'll add all these map entries to priority queue. So let's do that. For every map dot entry of integer and integer entries in map dot entry set, right, what we'll do is priority queue is of map dot entry, which is of integer type. This one will also be map dot entry integer type. So what we are doing is in the priority queue, let me go here. So let's say this is the priority queue, and it reorders itself, right? So all the entries of map, which is a key, and a value, right? 1, 2, 3, all these will be added here. So for us, if you look at this first example, it will be, since in this line we have kept, okay, 1 counts to 3, so the map will be like 1 occurs 3 times, this is key value. 2 occurs, I think, 2 times, and then 3 occurs how many times? 3 occurs once. So now whenever we keep all these entries in a priority queue, it sorts them based on the value which we need to write now. So that means this one has to come at the top so that we can use it, right? Let's do that. So, and all the entries, that is this 1, 2, 2, 3 key value pair, we are adding to priority queue. So now what we'll do is, okay, a dot get value minus b dot get value. So what we want is to put it in reverse order, right? So that means we need to put b dot get value minus a dot get value. So this is our sorting order, and here what we'll do is in priority queue dot add entries, right? So this is what we'll do now. Now your okay, k is always valid, and then okay, now so since we added all these numbers, what we'll do now is while this k is greater than 0, right, we can simply return an integer array, or so there are two numbers and there are also integer array. You can return answer in any order, it doesn't matter. So integer array of return is equal to new integer array of size. We need two numbers, right? So it will basically be 2, not 2, sorry, k. This one had 2, so I was confused. So what we'll do now is while k is greater than 0, that is k minus minus, we'll simply put return student I equals to 0, and return of I plus plus is equals to priority queue dot poll, poll, since this is a dot get key, right? Priority queue is map entry, and entries key is what we want to put in our return. So return, wait, hope this works. Let's see. Okay, there is an error. A B is what we want to map to this. Okay. Okay, this is fine. Now let's find the median. Median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value. If the size of the list is even, there is no, so the median is mean of two values. For example, 2, 3, 4, the median is 3 because this is the median, and for 2, 3, when the list is odd, the median is 2 plus 3. Design a data structure that supports the following two operations. Void add num, add an integer to the data stream, to the data structure, and find the median. Return the median of all the elements so far. Okay, so basically the median basically means, if you look at it, right, so whatever number we have, let's say we have a b c d e f g h I, so if this is sorted in, let's say this is in sorted order, then what we can see here, that this is the mid value, right? So this is the median for this number, e is the median. Now let's say if we only had if we only had this, which is 1 2 3 4 and 1 2 3 4, if this is sorted, then the median is d plus e by 2, right? So that is what our median will be. Now what we need to do is whatever number we add, we need to make two heaps here, so that these numbers are, one is in ascending order and one is in uh, descending order. So that way we can simply pull the two mid elements, right? So two middle elements, and then uh, do this while returning the median. And also, if they are of odd length, we can simply pull from one of the list on how we maintain. Let's say we maintain this on minimum heap, so a minimum sorted in max order, that is max will come first, then I mean max heap which has all the minimum values. In that sense, if the size doesn't matter, I mean if the size doesn't match, then we will basically return the topmost element of the that value, right? This element, uh, minimum heap. So for that, let's say we have priority queues again, priority queue of min heap and priority queue of max heap. So in the median finder, what we can do is min heap is equals to new priority queue, but this will be basically of integers, or everything we add here is integer. So let's just make it integer. And what we are going to do in min heap is basically sorted in. So this is we are considering these small elements as min heap and this as max heap. Okay, don't get confused. So let's say we have a and b, these two elements. What we are going to do is we want the maximum element at top, right? So we will basically do b minus a. Similarly, for max heap, we are going to do new priority integer, the same thing, but in the reverse order. I have been using JavaScript for a while. A minus b. Okay, now let's say when these both are empty, we can simply add the value in the min heap so that it always maintains this highest value, right? So let's say if we have different scenarios, if min heap equals to null and or empty, min heap dot is empty and max heap is empty. If both are empty, we can simply put, okay, min heap dot add this whatever number is, that is our minimum number for now, right? And then we can simply return from here. We're simply adding it. Now if let's say the midi, we have the value in mid, okay, let's say a was there, or let's say c came first, we added c came first in this list, and now we are going to add a, right? So we are going to add a. In that case, let's say, so now this c has to, so this c is in min heap, the new addition number is here. What we need to do to maintain order is this a needs to go to min heap and this c needs to go to max heap, right? Whenever we have just two numbers, because this is higher than the incoming value. So for that, let's say we have another situation when max heap is empty. If max heap is empty, then what we'll do is, okay, let's pull this value and yeah, so in max heap dot add, in max heap what we'll put is math dot maximum of this incoming value, which is num, or the value in c, that is min heap dot poll, right? That way, whatever is the minimum between these two number, which is okay, maximum between A and C, which is C, of course, will go to will now go to max heap. Max heap, right? Yeah. Let's not poll. Let's just pick because we will need it. Right. So we are just picking the topmost small value. Uh, okay. Now in min heap dot add. So since this is already greater, the other will be minimum. So math dot min of, and since we need to actually pop at least once, so we'll simply do min heap dot, okay, our heap is capital, min heap dot poll, right? Let's just do this. So now what happened is in max heap we added the maximum of A and C. A is our incoming value, so maximum of A and C is C. C now goes to max heap, and the minimum of A and C is A, which now goes to min heap, right? So that the order is maintained. Return, right? Now the condition is when both has the value in it. Let's say we already have some of these values. uh, Minimum stack is filled at least once, and max stack is filled at least once, or we have like this. Now since we want to maintain this order, right, we want to have equal numbers on left and right, and the min heap can have just one more of the right. So what we'll do is, let's say this situation, two situation arises. If the new number, the incoming number, whenever the size of these two are same, then the incoming number should go to the min heap, right? So let's do that. That means if min heap dot size equals to max heap dot size, if the sizes are equal, then what we'll do is, and if this is not equal, there are two scenarios. If that is not equal, then we need to put in the max heap, right? So in the min heap, okay, let's see, the incoming number is, okay, we already have a C and D here, and M and P here. Okay, this will actually be M, N, and P, right? This is how it is sorted, the max heap, not this, right? So now when these two numbers are equal and we want to insert, let's say we want to insert B, right? So if we want to insert B, what needs to happen is this B must go in the min heap, right? If the value is small than D, that means okay, it's here. Now if let's say it's Z, then what needs to happen is we need to pop out this value. This P must go here, because not P, M, which is the smallest of this largest set. M must go here and G must be added here, right? So that is what we will do now. So let's say our int min heap maximum value is equals to min heap dot what do we need, min heap dot pick. So this will give the maximum value, and int max heap min value is max heap dot pick, right? So we simply pick the values. Now if our num, right, if whatever is coming in is let's say is smaller than min heap, then that is good, right? We can simply, so based on this we can say, okay, if p is small than this, then that is fine. We can simply add it to min heap dot add this new number, right? But if it is not, that means it is somehow greater than this min heap max, right? But there also it can be two things, either smaller than this or not. So let's say if this num is smaller than max heap min, that means it still belongs to min heap, right? Min heap dot add num. But if it is greater, then what we need to do is we simply need to put min heap dot add. In min heap we need to add max heap dot pull the smallest value in max heap, and in max heap we need to add this number, right? Yeah, that's it. When the sizes are equal. Now this case arises when, so these two we can put it in the same if and else, that is if this or, but for the simplicity let's just put it like this. I didn't want this, so we could have simply kept it here. If num is less than min heap or num is less than max heap min, then we can simply add it here. Else else we can simply do this, right? Now the situation arises where, okay, the same situation, let's say we have a, so we added m on top, m d c a, and this one has n p and g, right? This one has n p and g. Now the next number, if they are not equal, then what we need to do is we need to add the value in max heap, right? So to add in the max heap, again different situation arise. Let's say we are adding b. If we add b, this b must go here, and this must come here, right? M must come here. But if it is already greater than n, then we can simply add it in this list. So that means, again, we could have kept it here. So okay, now else if min heap max, like here, if min heap max value is smaller than, like if it was qr, we can simply edit that family. So if min heap max is still smaller than number, then we can simply do max heap dot add. In max heap we can simply add this number. Else, if that is not the case, that means the number that we have is not greater, but it is smaller than min heap max. So that means what we need to do is in max heap, right? In max heap we need to add this m, right? So that means max heap dot add, and this will be popped from min heap. So min heap dot pop, that means pull, right? And in min heap dot add this number, right? So if we do this, then we have the queues ready. Just our data structure is there. Now simply when we are finding the medium, what we want to do is uh, if both the numbers, I mean if min heap dot size equals to max heap dot size, if the sizes are equal, then we can simply return this thing, right? Min heap max plus max heap min by 2.0. Else we can simply return min heap max, right? Because that will be our median, which I explained earlier. So let's see. What happened here? Priority queue of integer. Oh, why don't I look at all these things? Let's see what we have if minute max. Is that what we wanted to do? Okay, let's see. Whenever it only has one, why did it throw null pointer? Okay, okay, cool. Thank you guys. Thank you. Have a good night again. It's already 1, almost 1. Good night. Bye.